In this video, we will see how to solve Sudoku using local search. I assume, of course, that you know the rules of Sudoku. In case you don't know them, the goal here is to find a value between 1 to 9 for every cell in this 9 by 9 grid, so that on every line you have a different value, on every column you have a different value, and in every block, 3 by 3 subblocks like these ones, you also have a different value. This is a solution that violates some of the constraints. And for instance, what you can see here is that some of the cells have a color code that represents the degree of violation of each of the cells. So a cell will be red when it has a violation larger or equal larger than 2, and then it will be orange if it has a violation of 2 here, and it will be yellow if it has a violation of 1, and a cell without any violation will be green. Okay. For instance, here you can see that this value 8 here is present here, and it's also present here, and it's also present here. Okay, and also here. So you see that we have a lot of violations here. We have at least 1, 2, 3, 3 and 4 violations because of that cell. Okay, because of the value 8 here. This is why this one is red. This one is green because you cannot find another value that is equal to 2 on this line, and you cannot find another 2 on this line, and you cannot find another 2 on this block. Okay, therefore this cell is colored in green, and the goal, of course, is to have everything green at the end. And the only thing that that we will consider here will be moves that consist in swapping the values of 2 cells, and the goal will be to decrease the global violation here. So we will take 2 cells and we will exchange them. Okay. So every time you design a local search approach for a problem, you have to decide what will be the hard constraint that you will keep satisfied along the moves, and what will be the soft constraint that you will try to minimize the violation of. The hard constraint that you will keep satisfied is that every cell has every number from 1 to 9 occurs exactly 9 times. Okay, and this is what you will keep satisfied. Okay, you will only, and this will be satisfied at the beginning, and since we will only consider swap moves, it will remain a hard constraint that will remain satisfied. So I already explained a little bit here the violation semantics and the colors here and the color code. And so, as I said, the move that we will consider will be swap. So, for instance, here you see that we have 8, we have a 7. Then we will swap them. Okay, and this 8 will become here a 7. Okay, and that one will become 8. And this is what you can see here. Okay, and this is what you can see. And you can see that now these cells, they used to be red, and now they become green. Okay, and the violation has decreased a little bit here as well. And at the next iteration, we select 2 cells again, and preferably we prefer to select red cells because they are highly violated, and we will swap them. So that 9 will become a 1, and this one will become a 9. Okay, and this is what you can see here. Okay, this one here and this one here, and now you see that this one has become green and this one has become a yellow, and we have decreased a little bit further the violations. Okay, and so on and so on. We will keep selecting violated cells and trying to swap them and try to decrease the violation, the overall violation, until everything becomes green. A first idea is that maybe it would be better to enforce a little bit more difficult hard constraints. And the goal will be to remain a little bit more feasible than having the right number of occurrences for each number. Okay? And usually we will do that by taking some soft constraints and putting them as hard constraints. So this will be the new hard constraint that we will add, okay, this one. We will also maintain that we have a permutation on every row, okay? And so this will be true at the beginning and it will remain true along the moves. It's quite easy to find an initial solution that maintains that we have a permutation on every row at the beginning. And then if we only keep swapping cells on the same row, this constraint will remain satisfied. Okay, so that's not too difficult. And as a soft constraint, we would like to satisfy the fact that we have a permutation on the columns and on every blocks, right? This will be the soft constraint, and so as I said, we have one more hard constraint that each number from 1 to 9, okay, should be placed in every row, and we will keep that satisfied at the beginning and also along the iterations by swapping only cells that are on the same line, on the same row. In the next video, I will explain how to implement this strategy on top of a local search library that is implemented on the repository of the course.